All right, welcome everybody to this HPRC short course, the Introduction to Linux. My name is Wes Brashear. I'm an assistant research scientist with the HPRC. My background is in biology, so I got my PhD in genetics. And my job is part of my job is to help users in the life sciences domains to work on our systems. This is just a course outline. We have our introduction, then we're going to go into managing directories and files, and including some exercises with that. We'll go over some useful commands and tools. And then we're going to end today with customizing our environment and then doing remote access and file transfer with things like SCP and SFTP and things like that. All right, so how this is set up. For a lot of the interactive portions, what you're going to see are bold words, and those are going to be things like commands, and those should be entered explicitly. Italicized words are variables, so that's going to be dependent on the information that that command or program needs, and things that may be relevant to each specific user. So it may include things like paths to your scratch space or your home space. And the commands for you to type are going to be highlighted for the most part in green, and the output should be in blue. So first of all, Linux is just a family of open source Unix-like operating systems based on the Unix kernel. Mac is an example of a Unix-like operating system. The first Unix was OS or operating system was in 1969. Then, like I said, Mac, DOS, and then finally Linux was in 1991 by the great Linus Torvalds. There are a lot of different Linux distributions. There's actually even one of the base ones was developed here for a while, but that's no longer in use. Richard, were you familiar with that? The TAMU version of Linux? So if you go and look, if you do some Googling and look up like Linux family tree or something, you'll get this massive kind of genealogy of different distributions. And TAMU has one at the very base that's not been developed further. Anyway, so the Linux kernel, a kernel is just the lowest level of software. So what it does is it's the components that actually interface with the hardware itself. Linux is growing in popularity. Right now, I think it's actually even the second most favored operating system for gaming, even. So there's a huge gap between it and Windows, but it did overtake Mac. It's very stable, fast, and very secure. It's really well set up for having multiple users and doing multitasking, and it's very easy to share data and program securely within the Linux operating system. There are versions available for all different types of hardware. So we're running Linux on our clusters, but there's limited versions for your PC. There's lightweight distributions. If you've got a really old PC, that's not maybe 7-8 years old, that doesn't have the best hardware. There are lightweight Linux distributions that are designed specifically for that type of thing, right? So if you've got a PC that kind of can't run Windows anymore, Linux might be a great option. So some of the common Linux operating systems, CentOS, Red Hat, Ubuntu, which is probably the most widely used one for personal machines, Fedora, and SUSE. Does anybody have Linux installed on their PC? Right. What about you heard of the WSL, the Windows subsystem Linux? So that's one of my favorite things that came out of, I guess, I think it was Windows 10, was the ability to actually just do Linux natively. It's really nice. So like I said, there are thousands of these distributions and operating systems. We kind of define them as flavors, if you will. And there are three main flavors. Fedora, which has Red Hat, OpenSUSE, and Rocky Linux. So that's a lot of our, like our cluster, one of our clusters runs Rocky Linux, the other ones run Red Hat. We have the Debian flavor, and that's going to be Ubuntu. Linux Mint is another really popular OS. Pop OS is another one that's based on actually Ubuntu, but it's kind of developed for AI ML workloads. Kali Linux is a version of Linux that was developed for kind of defensive hacking. So for people that do kind of that white hat hacking, doing penetration testing and things like that. So it comes with a lot of tools that are could be considered malicious. It's an interesting operating system and deep in. And then finally, we have Arch Linux. And so that's things like Arch Linux, Manjaro, and Garuda. And that's a little more advanced, and I think it's still a stable flavor, but it's for people that have quite a bit of experience with Linux. All right, so what scares a lot of people off on Linux systems is the command line interface, because Linux really depends on that a lot more than say Windows or Mac, where everything is much more GUI based. So just point and click. I mean, those systems still have things like terminal or PowerShell, but Linux has a terminal that's used a lot more frequently. The CLI, that command line interface, works almost everywhere, and it's really fast and powerful. So once you get over that kind of that initial fear of getting onto the command line, I think that you'll start to favor it over doing things through GUI in some instances. Where you're going to be typing these commands is in a terminal, and the terminal is just a wrapper program that runs what's called a shell. And the shell is the command line interpreter, and it's a program that processes all of the commands and outputs the results. And there are a lot of different types of shells. Right? So probably the most common one is Bash, which is what we'll be working with. If you have a Mac, I believe that's RZSC, something like that. It's a slightly different flavor of shell. So yeah, like I said, so Bash shell is what we're going to be using. That's what's on our systems. There's also the Bourne shell, C shell. There's a lot of information about the different shells. We'll just be mainly focusing on explicitly focusing on Bash. Prompting. So this is the sort of text that shows up when you open terminal, and there is a format to it. And so on our systems, it's your username at the host name. So it'll be like Grace, and then whatever folder that you're working in. So you always have kind of an idea of where you're at within the file system when you open up terminal. And there are ways to modify that if you would ever want to. All right, so whenever you type in a command, the shell processes that command and then sends it to the Linux kernel. All of these Linux commands are case sensitive, and they all have this kind of common structure. So there's the command that you start off with, and then all of the options, and then for that command, and then whatever arguments that command requires. So ls is an example of a command. What does that command do? Does anybody know? Yeah, it lists the contents of the directory that you're working in. AL are the options. So we'll go over ls later, but A lists all the files, even hidden ones within a directory. L does it in the long format. And then to provide a specific path, we'll include this argument home/user/directory name. All right, so we're going to be working on Grace today for our exercises and to play around on the terminal. There are a few different ways of accessing Grace. If you're on campus, you can, if you have a Mac, you can just do the terminal and SSH in with your user net ID and then at grace.hprc.tamu.edu. If you are off campus, you'll need to have the VPN going in order to access any of our systems. There are a few SSH programs for Windows. We really recommend MOBA Xterm, but I believe there's also PuTTY.sh, and you can use the WSL. I think you can even SSH with VS Code, but we really recommend MOBA Xterm if you're going to SSH that way. And then for Mac, you can just use terminal. A few notes about getting onto our systems. Whenever you're logged in, you access what's called a login node. All right, so that's on Grace, one of 5 nodes that allows you to do like small jobs like scripting, anything that takes less than an hour to run, and it takes up 8 or fewer cores. So like a lot of the stuff that we do today, like making directories and writing scripts, you can do on the login nodes. For more extensive jobs, we need a lot of computational power. We'll have to write a script and submit it to what are called the compute nodes. And we have a lot more compute nodes than login. Oh, I should point out, you will not have an admin access. So that's what this sudo command gives you is kind of admin privileges. You guys don't have access to that, so don't use it. The best way, though, to access Grace is through the HPRC portal. So you just go to hprc.tamu.edu and select Grace portal in the dropdown. So I'm going to do that right now. All right, so I'm at hprc.tamu.edu portal, and we're going to be on Grace today. All right, so and if you're not logged in through CAS, it's going to ask you to log in. And then to access, you just select Grace Shell Access from the clusters drop-down menu. So right here, Grace Shell Access. That's going to open a new tab. All right, and so here I'm prompted to put in my password and do 2-factor authentication. So what pops up first on our systems is this nice long message. So we've got all of our contact information up at the top, and then our website, consulting, and then links to all of the different websites that we have for our different systems. So we have quite a few clusters, and like I said, you guys should know we're on the Grace cluster right now, which is the university flagship system. And then we have our YouTube channel where there are a lot of videos that you can go and look at old videos of short courses over different topics that may be of interest to you. Then we have some policy information, and right here we'll see the message of the day, which is important to keep an eye on. If you're frequently on our systems, it'll show things like, hey, we've got scheduled maintenance, 2 days from now, just so that you're aware of what's happening. And then finally, this last part is showing my quota and the amount of space I'm actually picking up. So in our home directory, that's the smaller directory, you're allotted 10 gigs of space and a 10,000 file limit. That's for holding things like job scripts and things like that don't take up a lot of space. The Scratch is for holding like larger data sets. It's not backed up. If you delete something off of Scratch, it's gone forever. There's no way for us to recover it. But you do get more space there. Most users have a 1 terabyte limit there. So, all right, let's see. All right, so the first exercise, we're just going to display the current shell name. So to do that, we're going to do echo. Let me make this bigger for you. Is that good? Okay. echo, and then $, saying that it's a variable, 0. All right, so now we know we're running a bash shell here. All right, we can also do just some basic stuff. Who am I? I am W. Brashear. All right, and then one that you'll need today is clear. And that's just going to clear your terminal so that it's nice and tidy. All right, are we all good to move forward? All right. So the course material for this is available on our website. If you go to the training tab and then go to courses, you guys should have seen that as you registered for it. We'll also be using a folder that's provided in the training Scratch space called fundamentals_Linux. So the first thing we want to do is move to our Scratch space. So whenever we log in, we're automatically in our home directory. We're going to go to our Scratch space. That's saved as an environmental variable called Scratch, all uppercase letters. And that's going to be to your own personal Scratch directory. All right. And notice that this is all caps. We'll talk about this a little bit later, but the environmental variables are going to be done in all caps. And we designate those variables with a $. So cd Scratch. And you can see now I've moved. We have that little tilde showing it's a home directory. Now I'm in a Scratch directory that's my username. And then we want to copy our the folder that we're going to be working with. So does anybody know the copy command? CP? Yeah, it's pretty easy. All right. Then we're going to do -R, which is recursively going to download all of the contents of the directory that we're interested in. And we're going to go Scratch, training, fundamentals of Linux, and then we're going to put a period. All right, does anybody know what that period stands for? What? Current directory, yeah. So we have the source, right, is an argument, and then the target. All right, so essentially what you want to copy and the destination. So hit enter, and it's going to copy that. So now I can do ls and see that I have fundamentals_Linux in my Scratch space. I'm going to go ahead and change my directory into that. It's fundamentals Linux. And so you can see now, again, my prompt's changed. I'm in fundamentals_Linux. All right, so we're going to move on to managing files and directories. So all the files and directories appear under the /root. The actual /root is the root user's home directory, which is not the same as just plain /. And so this is kind of the hierarchy of how we're looking at this. We have root, temp, etc, and then home. And then in home, we have Sarah and Chris. So you can see Sarah and Chris, so home/Sarah/Chris. And then within Chris, we have docs and scripts. And so that's how it's organized into directories and subdirectories on the Linux system. It's very typical and straightforward. So most Linux file systems are going to be case sensitive. So if you try to do cd home Chris and then uppercase D, it's not going to be able to find what you're looking for. A useful command, especially if you're moving around a lot, is going to be this pwd command, which prints your working directory. Right. So especially if you're bouncing back and forth, sometimes it's useful to type in pwd, or if you need the full path to where you are instead of just your current directory, pwd will give you that full path. And we talked about this a little bit. So we have absolute path names. Those are going to be explicitly stated with they start with the slash. And we also have what are called relative path names. So the period, the dot is just your current directory. If you want to move up a directory, it's 2 dots. And then this tilde takes you to your home directory. So let's play with that a little bit. So if I just do pwd, again, that's going to show that full path. Scratch/user/wbashir/fundamentals Linux. To move up a directory, I'll do cd 2 periods. That's nice. I'll go back in. And so you can start doing things like we want to list the contents of the directory above, do ls, and say I want to do, all right, ls. So I can get the contents of the directory ncbi from my current working directory, which is fundamentals of Linux. So using that relative path of dot, go up, look, and then look for this, come down. To make sure that you're getting the path correct, I recommend using like tab to autocomplete the path so that, well, it makes it quicker, A, and then B, you can be sure that you're typing in the correct thing. All right, any questions on that so far? All right, so go ahead and do this example here, the ls. Let's see. We've already talked about this. We can do the ls and then the directory name. And we talked a little bit about some of these flags. So A is going to print all the files, including the hidden files. So how are files hidden typically in Linux? Does anybody know? They start with a period. So if you look in your home directory, go ahead and do ls space the tilde. All right, and then do ls space -a in the tilde. All right, so I'm going to do ls like that. All right, so looks like I've only got 10 files here, 10 files and directories or whatever. However, I know that there's quite a bit more. Right, so all of these different things we'll talk a little bit about later. So things like -rc and -profile, which we'll use to modify our environment later. All of these things are hidden from the normal view. All right, the L command prints a long listing. So instead of just doing that kind of like block of stuff, it makes it easier to list it. -C does the list entries by columns, and -F will print a special character after the special files. So let's go look at this. So let's say I'll do ls -al. All right, so that's showing all and in that long format, which is a lot easier to read. All right, so another thing I want to find out, what's this right here? Size. All right, is that very readable? What if we did ls alh? All right, so we're making that more conducive to reading. So 4.0 kilobytes is a lot easier to read than 4096. So especially when you get to larger things, it becomes, if it's in the 10, 15 gigs, it's really hard to see. So H is a really another commonly used one. If I want to, well, it won't work here. If I do ls lhr, that's going to do, it's going to order them in a certain way, so that the one that was updated last is going to show up on the bottom. So there's a lot of different flags that you can use. If we do man ls, that's going to pull up what's called the man page for ls, and it's going to show you all of the different flags. So this is really useful, and there's man pages for most of the commands that we're going over today. Hit Q to get out. All right. Clear. All right. The next thing we want to look at is called tree. So if we type in tree, it's just going to print out this really nice topology of the directory that we're working in. So I didn't include any arguments there, right? So it's just going to use the current working directory. Let's try this tree. All right, so now it's going to build out a really extensive list of all of the files I have. I'm going to go ahead and quit this because I know I've got hundreds of thousands of files, and I don't want to spend 4 minutes looking at them all. All right, so that's how tree works. You can do it without the argument, and I'll just do your current directory, or you can provide a relative or a full path to reach out or to produce that topology. We're going to talk a little bit about file and directory names. This is something that can cause you a lot of headaches, especially going between like Windows and Linux, or trying to run certain programs. If your file names are in a weird format, then it may throw an error with the program, or cause things to appear to Linux that are interpreted differently in Windows, things like that. So some commonly used things to name files, of course, can be your letters and numbers, periods, dashes and underscores are always good things to like separate long file names. Do not use spaces in the file names. This is a terrible habit. All right. So if you want to call something like my data file, you can do that like on Windows, right? And make it nice and easy to read. But it can throw Linux systems into a fit. So what we want to do is my underscore data underscore file to have it more readable. Or you could do something like my in lowercase and then capital D and then capital F with no spaces or something like that to make it more readable. One thing we want to do is creating files on your Windows computer and copying those to Linux. There are certain like hidden characters and things that can really mess up what's going to be displayed whenever you like create a file. Especially, I've seen people try to do stuff in Word and then take it over to Linux and open it, and it looks completely different. And it's a mess, right? So there are some programs that are less prone to issues like that, but it's always best just to kind of work in a Linux system and create your files there. And then some things to not use, of course, and oftentimes it won't let you even save a file or rename a file if you use any of these. But any kind of punctuation outside of the period, dash, or underscore. Those can mean different things, right? So we've already seen the $sign. What does that mean in Linux? It's a variable, right? So it's going to try to look up this variable in your that's in your name that's not there. So, all right. So to make directories in Linux, we've got this really nice command called makedir. So this is one of the things I really love about Linux is all these commands make a lot of sense, right? So mkdir, and then you just provide the name of the directory that you want to make. So go ahead and make a directory in this fundamentals of Linux. We'll name it temp. If we do makedir and then the tilde, where is that? And then /temp, where's that going to end up? In your home directory, right? And that's going to be that relative path that we talked about. Or you could do it explicitly with home/netid/temp. All right. So let's see, ls-l. So those things, I'm going to do makedir temp ls-l. All right, and so now temp is there. All right, instead of ls space dash L is not a long command, right? What if I wanted to repeat a longer command and I didn't want to type it all out again? What could I do? The arrow, yeah. So that's going to go through, you can go through your history that way, which makes it really nice. All right. All right, to move uh, directories or files, we use the mv command. And so we just provide the, again, the source and the target, so the old directory name and where we want to move it to. You can also use this for renaming a file. So you just provide the old file name and what you want the new file name to be. And again, the paths are important on all of this. So it's going to look, if you're just providing old file name that's in your current working directory and a new file name, it's going to put it in your current working directory. If you're trying to like move one file from, somewhere that's 2 directories up, you're going to have to provide the full path for Linux to be able to find it. All right, and then there's one flag in move. I don't use this. The -I, it's a safe move. It asks for your permission to type in the command, and then it'll ask for your permission if you are going to like actually overwrite a file. So it is much safer to do if you. It's really easy on the command line to wipe out files by doing something like this, moving it to like a new empty file into a file that's already existing, and it'll just replace everything there, and you won't be able to get it back, right? So that -I is a nice flag to ensure that you're not overriding something. So let's play with that a little bit. Let's see. Go to. I want to move temp to temp2. All right, we did. If I want to move test1, let's do the I, to test2, ruh-roh. All right. Why did that not work? Jeez. All right. Oh, that's for files, not directories. All right, so that's my fault. All right, so that the -I doesn't work for directories, only files. All right, let's go back. All right, so this is something that we've already seen, the cp command, which copies files. We use that to copy that full directory from the training directory in Scratch to your current Scratch space, your personal Scratch space. Whenever you're doing a copy, you cannot have a file that has the name of the file that you're trying to copy. So in that case, you'd have to rename as you're copying to a different file name. You can copy a file into a directory by just specifying the file you want, and then the directory, it'll just copy it straight into there with the same name as the original source. But you should have that directory already named. All right, or if you just move it, if you try this file name to move to a new directory and create that new directory using this copy command, it'll just rename the file or copy that file that name. And again, we have that -I for safe copying if you're going to overwrite a file. Another flag is the -R, which makes a complete copy of the directory, including all of its contents. and names it to a new directory name. So again, you'll have to provide that -r is means recursive. So it's going to get all the subdirectories and all the contents. All right, so to delete a file, we'll use the rm command, which is just like remove. And so again, it makes sense. Safe delete, again with the -i. So a lot of these commands, it's really nice. They share a lot of the same flags, especially for like data management, those type of tools. And that will prompt you for confirmation before deleting the file name. To remove a directory, if it is empty, you can just use rm dir and then the directory name. If it has contents, you have to provide that -r flag. All right. So this is something I do want to touch on. Once the file is deleted or overwritten, like you can't get it back. So if you're using wildcards, which we'll talk about later, which allow you to kind of like match a certain pattern. So I'm just going to ls, and then if I do ls, here we'll talk about it in more detail later, but I use an asterisk test, an asterisk, and it's going to go in and grab ls, anything that's got test inside of the file name or directory name, right? But if you're using rm and you start using wildcards, you can accidentally delete a lot of things, right? So it's very dangerous. There are a lot of trolls online that will do things like, to fix that, you just do, rm-rf, and that's gonna force remove everything and like delete your entire system, right? So just be careful of whenever you're doing anything that says rm. I've even seen commands written in like hexadecimal to trick people into doing that, which is a whole new level of cruel. All right, any questions on that? All right, did we try all of those commands? Everybody happy? Oh, let's try that real quick. So ls, we'll just do this rm test2. All right, so cannot remove, it is a directory, right? So we'll have to do rm-r test2, and then it does it, right? So ls, and it's gone. So what I'm gonna do, because I messed this up, rm-r fundamentals Linux, and then I'm going to copy scratch training. All right, so now I've got a fresh, clean directory to work in. All right, so here's an exercise for you all to go through and try the commands that we've learned so far. Please do all of these steps. You can add in additional steps if you'd like, doing the RM and CP and things like that. I just want to give you guys a few minutes to test it on your own and get familiar with all of the commands that we've just learned. Just change to your, the CD. You just do CD blank, it'll automatically go to your home directory. To print your working, to make sure you're there, just do pwd, list of contents with ls-a, and then we made 2 directories, and then did a tree. So if I do cd, all right, so you can see again that prompt changed, ls-a, all of those different files in there, and then make their temp1, after temp2, and then a tree. Okay, I'm going to stop that. I've got a lot of different like packages and stuff installed in there. All right, so, all right, those are like the basic commands, right, that you need to navigate the system. It's all really kind of that first entry level into Linux. We're going to start going over some of the things that are a little more complicated. So don't fall asleep if you knew all this already.
we are going to cover some things that I find to be a little more exciting. So we're going to start off, though, with more about directories and files. All right, so whenever we do the ls-l, that's going to print it in that long format, right? And so it gives you all of this information. The first right here, does anybody know what this is? Your permissions, number of hard links or files that are inside that, the name of the file owner, the name of the group ID, and that file size in bytes, and then the time the file was last modified, and then finally the actual file name. All right, so it's a lot of useful information whenever we include that L for the long format. So this is confusing to a lot of people. It's something that I still often have to look up if I'm like changing permissions on something. Is how this is formatted. So essentially, you have 3 different sections within your permissions. You'll have the user, the group, which is whatever group you belong to, and then others, so people outside of that group. So then you have 3 things, right? So the read permissions, the write permissions, and the executable permissions. So for here, the user has permission to do all 3: can read, write, and execute, right? Which makes sense. The group can just read and execute, and then people outside of that group can only read the files. They can't do anything else with them. So this is where things can get kind of dangerous, right? So let's say this is set up to be RWX for all 3. All right, and we've had issues with this on our system, people setting permissions on files like this, right? So what would that mean? You can do anything in that space, right? So you could somebody could go in and write a file there that deletes everything in your scratch space, or does something else that's malicious. All right, so permissions are something that you want to be careful with whenever you're setting. Don't ever do does anybody know the command to change permissions? Yeah, chmod. You say chmod? Chmod, okay. Yeah, so don't ever do, we'll go over chmod in a bit, chmod 777 on a file. It's never a good idea, okay? You'll get a nasty, well, no, it won't be nasty. You'll get a nice letter from one of our sysadmin people saying like, hey, don't do this, or they'll go in and mess with your file and leave a note saying, hey, this is why you don't do this. Here's that chmod command. There are 2 kind of different ways of doing this. You can use the letters. So if you do chmod u plus x, it's just going to add executable permissions for the user. All right, and then you don't have to include the file name after that, or the directory name. If you do chmod og minus r, that's going to remove read permissions from others and from the group. If you do chmod dash capital R and then A plus RX, that's going to give everyone read and executable permission from the directory name and then all the way down through all the subdirectories, all the way through the hierarchy. All right, you can set the permissions using the equal sign, so the user can have read, write, and execute. And then same with the G for the group. All right. We can also use numbers, which there's pros and cons to both, right? This makes this isn't as clear as to what's happening, right? But it is a lot easier to type. And if you have 755 is a roll calling, so you can just chmod 755 on something that you want to give others the ability to the others and the group the ability to read and execute, but you're going to be the only one that the user is going to be the only one that has permissions to run that. 600 is another one that provides read and write for the user only. And there are, if you Google it, you can they're like quick tools to calculate the values that you want. That so. All right, so there are a few different tools for looking at like the contents of a text file. Less and more allow you to kind of scroll through. If you have like a long text file, you can go through those. Less has more options than more. They're terribly named. Those are two I don't like. Cat will just print out all of the text and put it once and stop, so it's not really interactive. Cat can be dangerous if you start doing things like piping or redirecting output. So more and less are going to be safer in that sense. If you do cat uppercase A or dash uppercase A, it's going to show all the hidden characters in that file as well. Which is handy, especially if you are doing something like transferring files from Windows to a Linux system. Head is just prints out like the first however many lines of text that you want to see. You specify that with the dash in. Tail is the same thing, except it prints out the last few lines. And then this is something it can be used to monitor a process. If you do tail dash F, it's gonna grab the last 10 lines and waits for new lines until you stop the command itself using Control C. So if something's like outputting and you're waiting for it to reach a certain state, then you can tail F that output log or whatever. And once you see, it reached that state that you want, then you can kill the tail command and then go on to do whatever it is that you need to do with whatever program you're running. This is something that I use every day. Very, very handy. All right. It's those wildcards that we talk about. So there are some different wildcards. Asterisk is going to match any character. So if we do like ls test asterisk, that's going to match anything that starts with test. It's going to hit. The question mark just matches one character, so it won't, keep going after. If you had like test 2 _ character or something like that, if you did the question mark test question mark, then it'll only do that 2 and replace the 2, not everything that follows it. The square brackets match a single character for a specified range of characters within the brackets. And then you can start getting in like curly brackets. And the most commonly used ones, though, are going to be that asterisk and the question mark. So here's some examples. So if we did NV, anything that starts with PROJ1 star, and all those files that begin with proj1 will be moved into that project1 directory. But that directory already has to exist. But if you have like proj1 dot text, proj1 dot log, proj1 output results, proj1, it'll grab all of those files and move them into that project1 directory. If we do ls proj question mark dot log, then it's only going to look for patterns that match that specific length of text that you put minus that one character. All right, so it would pick up proj1.log, proj2.log, but it wouldn't pick up proj1.text. Here we're using the square brackets saying move enzyme 1.2.com to this enzyme directory. It's picking up enzyme1.com and enzyme2.com. And then finally, if we do this curly brackets, and then now we're looking at everything that ends in .com, everything that ends in .log, everything that ends in .text, and move that to the directory project 1 through 5. Another thing that's useful is the find command, which allows you to look for a specific file or directory. So the first thing you do after find is provide where you want to search. Right, so we're searching within the current directory, specified with that relative path, the period. And then we're saying dash name, and that's going to say you want to search for this particular string. And then you provide whatever string that is. So in this case, it's going to be any files that contain test1. If you use iname instead of just name, it makes the search case insensitive, which is nice. So this one, I will say that this one isn't as intuitive. The dash name argument is something that you have to remember. If you don't use it that often, a lot of times you'll just I have in the past just done like find period and then put in a search string without specifying the dash name. So just something to keep in mind. All right. grep is a very powerful tool. It's one that I use absolutely every day. It searches for a pattern within a file name. So if let's say in this file run1.out, if I did grep energy run1.out, it's going to search that file, kind of read through that file, and pull out everything, every line that has energy in it. And it is case sensitive. So if you want to look for capital energy and lowercase energy, you would have to use the -i flag. All right. If I wanted to grep energy in all the files that sit out, I can just use that wildcard, and then that's going to grep and pull out all the lines that say energy in all the files that end in out. If you want to search for a phrase or something, you're going to have to use quotes around it, which makes sense, right? So in this example here, we're searching for that phrase total energy, and we're looking in any directory, in each directory of the current directory. So star, right, / any file that ends in out, or asterisk / asterisk. So if we are looking in like our fundamentals of Linux folder, it'll look in test1, test2, test3 for any file that ends in out. And then again, you see that -R recursive, all looking for total energy in all the files under the provided directory, so project 1. egrep is another one that's used. It's really just kind of a shortcut for using grep with the -e flag. It allows you to look for regular expressions. So it'll search, if we do egrep, we can provide multiple patterns to search for, and it'll search whatever that file is for all patterns and then print those results to screen. All right, this this vertical bar is what's called a pipe, and it's located here on your keyboard. It's something that we'll be using, if not in this course, in the intermediate one, where we start to do a lot of fun stuff. But essentially it's, taking input and putting it out, typing it typically, but here we're using it to search these multiple patterns. All right, any questions on grep or egrep? All right, so we want you guys to go ahead and try this command right here. This is how we get a file from a URL. We use the wget command. You have internet access on the login nodes. Those are connected. If you're on a compute node, those do not automatically have access to the internet. So you'd have to specify that. But we're working on the login nodes on Grace. So if you want to get this file, we can just do wget and then provide the URL. All right, so let's move on. I'm going to put some commands over. I'll show these on the side screens, and then work through them on the terminal here. So if I do the file command, it shows that we this DOS underscore script dot sh is ASCII text, but it has these CRLF terminators, right? So carriage return line feed. Xandra, is that a throwback to typewriters? Sorry, interesting thought there. So Windows editors like Notepad, which is the basic, right, Windows text editor, which just don't use, like get another one. All right. They'll put in these hidden characters, and that's going to cause a lot of problems in our Linux environment. All right, we do have this command DOS to Unix that will convert these characters or these files into a Linux-friendly format. And this is something that we see at the help desk pretty frequently, is that like we can't get this application to run. It's like, well, you've obviously done something from Windows and copied it over. You've got these characters that it's flipping out over. Just run this, and all your problems will go away. All right, so to do that, we just type in DOS to Unix and then the file name. So DOS to Unix. All right, so then it says converting file DOS underscore script dot sh to Unix format. And then if we do file again on it, so now it's showing that it's just ASCII text and it doesn't have those CRLF line terminators. And I can't stress how many times we see this as an issue. All right, can't stress that enough. All right, so are there any questions on DOS to Unix? We're aware of it. So we've done all of that. We didn't move it to temp1. I guess we can do that now. How do I move that file to temp1? MV. Then what? DOS script.sh. All right, the source and then the target. Where do we want to move it? Uh-oh. All right, what's going to happen if I do this? Yeah, all right, so let's do this. See, ls. All right, do I have a folder named temp1? No, so if I do move DOS script to temp1, it'll do it. It did it, right? What happened though is that now it's named temp1, right? It's not in a directory named temp1. So we can do move temp1 to DOS script.sh. And then now, how do we make a directory? mkdir, mkdir, and then call it temp1. And now we can move DOS script.sh into temp1. And then ls, it's not there. Is it in temp1? Yes, it is. All right. All right. All right, so now we're going to move on to some more useful commands and tools in Linux. The greater than symbol is a way that we can redirect text. All right, so if we say, we do this command, here we're doing ls-al
And then we're sending all of that to a file named list of files.txt. If we do 2 of those, it appends to the end of the file instead of overwriting it. All right, so let's try this. Let's do and clear this ls-a into files.txt. All right, and then if I do cat, remember cat, files.txt. That's a file that I've got in there. All right, so now let's try that again. All right, files.txt, and then let's do cat again. All right, you can see if we did the single greater than, it's going to overwrite it. And so that's what I was talking about earlier, that like things like cat can be very dangerous if you're trying to like write out a certain, portion of a text file, large text file or something. If you cat accidentally, you can overwrite or use this, the greater than, you can overwrite what you're trying to send it to. So it's just something to be very careful of. So if we do, now let's try it. Yeah, let's do cat, file, what's it called? Files.txt into files.txt. Let's try that. All right, didn't like that. All right, but if we do ls-a files.txt, ls-a, don't need the files.txt, I'm sorry. I'm going to keep doing this for a while. All right, so now what have I done? In files.txt, if I do cat files.txt, so cat prints out all of it at once, right? Remember? All right, what can I use just to start scrolling through it? Instead of, do what? What command can I use if I don't want to print it all out at once? I just want to start going through it line by line. So we're going to try less files.txt. And so now you can see it's not doing all of it. I can start going through either if I hit enter, it's going to go through line by line. If I do space, it's going to go kind of take bigger jumps, do a page at a time. So that's the difference between that less and the cat command. Does that make sense to everybody? All right. And so now, like, I've reached the end of the file. It shows me end of the file. And to quit it, though, I'll just do hit Q, and it'll stop. Okay. We can use the less than to redirect input. So if we have, I don't know, like we want to feed in a certain thing into like a program or command, we can use the less than to feed that into it. All right, so we talked a little bit about pipes. They're very handy. All it does is it takes the output of one command and it sends it to another. So here, if we do ls pipe more, it's going to allow us to kind of go through the list of files as it interactively and not just print them all to screen at once. If we do like a grep, and if instead of using, remember you can search for multiple terms using like the egrep, we can just grep this one file and then grep again by grepping for your energy, run one dot out, and then piping that into a new grep where we're looking for HF. And then if we wanted to put the pipe and the greater than together, we can do that and put everything out to a file named hf_output.txt. All right, any questions on pipes? All right.
All right, so we talked a little bit about this earlier. There we go. And that's the history. And so we talked in the context of like just looking for a command you ran recently, just you doing the up arrow. All right, so that's just going through your history, looking for the commands that you've run. That's also available if you just type in history. If we do, let's see, let's just take a look at that. So history every time. All right, so that's going to print out all the things that I've done, all those the last commands. Now you can see there are a lot of commands going back to stuff I was doing, yesterday, the day before, and so on. So if you don't want to scroll up though, you can instead of scrolling up to find the command, you'll see they're numbered here. So I can just do what's really handy is an exclamation point, 1079, and it reruns that command. All right, so it's kind of fun, right? All right. Something that I do frequently is I'll use grep on my history. So instead of scrolling through, 1,000 lines of commands that I've run, so for example, I know we did wget. What was the file that we pulled, right? I can do history if I could type, all right, and then grep wget. Oh, there it is. Okay, these are all the commands that have wget that I've run recently. All right, and now this one being the most recent, right, that we used to pull. And you can see I've used wget for all sorts of other things too. All right, so history and grep go together like PB and J. I love it. All right, so we've also talked about the tab for the auto completion, right? That's very handy, especially again if you want to make sure that you're getting the path correct, so that you're not typing in //user /temp1 /subdirectory2 /subdirectory A /text.text. If you have one typo in there, it's going to mess everything up. But if you autocomplete, then it'll make it easier to type A and then B, ensure that you don't have any issues finding what you're looking for. All right, so are you guys familiar with compressed files? I think that these are fairly common. They're, I think, a lot easier to handle on Linux systems versus like a Windows system. I haven't worked on Windows in a while, but don't you have to like download a program to decompress certain files? Like I don't. It's really easy with Linux on a command line. To zip up a file, you just do the gzip, and it'll create the file .gz. For -v or -v will print in the verbose mode and tells you the percent compression. -r, again, recursive, so it zips all the files down the hierarchy from the directory name. Gunzip is just how to decompress that file name.gz, and it creates a file name. You can also use gzip-d. And there's also bzip, which is a different compression style, and bunzip. So let's look at these real quick. So where am I? Let's go up. If I want to do gzip-rv. All right, so it was in verbose mode, right? So it printed out all this stuff that it was compressing, the amount that it was compressing. So you can see we've got some decent compression in here. Now, if I want to, let's see, ls. All right, so now everything in here is all these files are gzipped, each individually compressed because we use that -r. If I go up, let's try this. Yeah, it's a directory. All right, so all those files in it are already compressed. If I want to do gunzip -r, go back in there, and now everything's decompressed. Right? So a lot easier to do. So this is one of those times that I would prefer the command line to doing like a GUI app, right? Where you have to go in and it's like Windows like extract all, and then like where does it extract to? And it's just kind of cumbersome, I think. It's a lot more cumbersome than just doing this method. All right, so another common method of like archiving and compression is the tar, right? So to either extract or archive, we'll use the tar command, and what changes is using either the X or the C. So -xpvf, and then the name of the tar file is going to extract all the contents of that tar file. If you use tar -cpvf, it will put all of those into the file name .tar that you specify. So that C flag again creates that new archive. That X is extracting. P is preserving protection information. B verbose. F, you're working with files, and then you can do other things like Z, which uses a compress program when reading or writing to the archive to make it smaller, and T, which lists the table of contents for an archive. All right, so let's try these. Is there a tar file in your fundamentals of Linux? Why don't you try some of these commands out on it? Let's see. So to extract, we'll do xpvf. And that created the readme.txt, which we already had. It should have been removed. More readme.txt. All right, so this is a file for the course of Fundamentals of Linux. All right, so if I wanted to compress this, I would tar readme.txt. Oh, excuse me. cpvf readme.1 .tar readme.txt. And so now I have another tar file there. Are there any questions on tar or GZ and BZ compression? Tar is one of the ones I always have to look up the flags for every time. All right. All right, so we have another one, the zip, right? So again, like on Windows, you'd have to download like 7-zip or something like that, right? Don't need to do that on Linux. You can just use the zip command and the unzip command to create these files and decompress them. All right, so let's go ahead and let's do it. We're here. This is good for our muscle memory. So I'll do clear, I'll do ls, and then I want to zip and archive the files in test3. and I'll name that test3.zip, and then I'll be doing test3. All right, so now I've got this test3.zip. It's slightly smaller than test3 original, right? So it's easier to share and quicker to transfer between systems and things like that. And then unzipping it, we can just do test3.zip. Uh-oh. So we already have this directory here named test3, right? That's what we zipped. And now it's asking us to replace this file or not. So we're just going to say replace all, and we've done it. Inflating. So see, again, much easier than some GUIs designed for this purpose. All right, so let's move on to a new topic. We're going to be going over customizing the environment. So this is really handy, especially if you're doing, you find yourself typing in the same command in terminal over and over and over again, and it's a longer command. You can do something like make an alias for it, right? So that you only have to type in 2 letters and it'll run the full command. But before we get to that, we're going to be talking about environmental variables or variables in general. So like I mentioned earlier, environmental variables are done with all caps. And these variables store information that's used kind of across the entire system. If you want a specific variable that's your own variable, you'd use lowercase to help distinguish between those environmental variables and kind of your local user variables. To see the contents of a variable, you just run the echo command with the name of the variable that you want to check out. So for instance, we've already done this, right? So echo scratch. We can see that the contents of that are just the full path to my scratch directory. And it'll be different for you, right? It'll be your username. So there are 2 important files for customizing your bash shell environment. There's the bash RC and the .bash_ profile. So bash RC is going to contain aliases, shell variables like your paths, where it's looking for executable information or executable files, things like that. And it's executed, or what we call sourced, whenever you start a non-login shell. The bash_ profile also contains these things. This is what's normally used for terminal settings. And this is what's executed once you log in, like upon login. All right. So what we want to do is we'll look into modifying our bash profile. Yeah. So that we'll build an alias or something together so that's present whenever you log into Grace on the system. So the bash profile contents are shown here. It's very similar to other kinds of scripting languages or things like that, where we've got the commented outlines beginning with the hashtag. And then we're enabling here the settings in this if command. We're looking for a .bash RC file. If it's there, then we're going to source it, let it run. Then the next line or bash right here is going to be your path. So if I do, let's see. Echo path. So these are all of the different directories that are located in my path. So if I type in a command, this is where it's going to start looking for either that executable or that command. All right. If you mess this up, you won't be able to run anything. Okay. So if like you erase your path, then it won't know where to look for commands or executables. So be careful whenever you're modifying your path. All right. Let's see. Let's just play with this. So here. All right, so what I did was added in, I exported a new path. So setting that path variable equal to the path that was already there, plus this fundamentals of Linux path. So just one way to kind of modify your environment on the fly. All right, so this next batch here, let's go into switch mode, is for personal aliases. So here we're saying alias H equals history piped into more. The alias M equals just more. So those are where you can get really creative with your own personal setup on things, which is really nice. So let's just try that real quick. Actually, last this user-specific functions. If you come to intermediate Linux and start to learn, awk and set things like that, you can set up things like this, where if you type in cc test at the prompt, then it's going to execute this full command here, awk-f cc.awk test log, and then write that out to test.cc. All right, so you'll just have to type in cc. That's the not cc test. It's a typo. All right, so let's look at aliases a little bit more. All right, so if we do alias H equals, let's just say history. That's pretty nice, right? You can do, I don't know, something silly, alias D equals, let's say echo alias D. No, let's just say, ooh, I don't know about this. Okay, yeah. So here it's just whenever I type in D, and now it's just going to run this command echo alias. So I just did that alias. We could do something like path. All right, so now I just typed in D to get my path instead of having to type in echo path. And so these can be modified in your bash profile. So if we go to our home directory, all right, ls, wait, where is it? Does anybody, where's my dash, my .bash rc and .bash profile? It's hidden, right? Why is it hidden? Starts with the period, right? Okay. How do we show hidden files? Dash ls dash a, yes. Oops. All right, you guys are getting it, right? All right, so that's good. All right, so now, if I wanted to, hold on just a sec. All right, so to edit this, don't do this yet, okay? I'm going to do something called VI, which is a command line based text editor. So don't do that right now. We'll go over VI a little bit more later, and a lot more if you come to intermediate Linux. VI is very powerful, but it's also kind of confusing. All right. So I'm going to VI though and look at my bash profile. All right, so you can see, I've got that in a weird spot. I've got, that's hard to see, two aliases there, and I can go in and add another alias and modify in here. So if I go, I need to modify my bash profile. And I want to say alias, all right. So even though I modified my bash profile, it wasn't run until I went back and sourced that file. All right. I could have logged out and logged back in, and it would have picked it up, but I didn't want to do that. So I just reran the sourcing of that file. And so now every time I type in dogs on Grace, it's just going to say woof. All right. So that's where you can have a lot of fun with it. On Grace, you can go in here and go to back to that dashboard, files, go to your home directory. All right. Again, where is it? It's hidden. So we've got this show dot files. And if you do want to play with it, I would suggest going in and clicking this and edit, and that's going to bring up something that should be a lot more familiar to you, right? So what I'm going to do is take this out because that shouldn't have been in there, and I'm going to just paste it down here. All right, so take some time. I'll click save here. And then let's change this to echo. I love dogs. All right, save. And then what do I need to do? Source. And then there we go. All right, take some time, a few minutes, and go in and create your own alias. It can be something much more useful, like getting your history or something like that. But go ahead and modify your bash underscore profile, source it, and then run whatever alias you created. All right, so I showed you guys how to do editing through our portal, which is really nice and helpful. It's a very user-friendly format. In this case, like GUI is a really good way to go. We do have some CLI editors available. I did VI or Vim is what I used. There's also like Nano and Emacs. Okay, yeah, we're going to go over the basics of VI here in a minute. But I encourage you guys to come. I think in like 3 weeks, we do intermediate Linux, and we start having a lot of fun with things like VI. And you can learn that. It's what I use now after having worked at the HPRC for over a year. It took me a while to be comfortable with it because it's kind of confusing at first. You can also do outside of the portal, if you want to edit in graphic mode, if you SSH into our system using X11 forwarding, you can do something like gedit, and it'll pull up gedit on your machine, and you can edit the file that way and save it, and then it saves back to Grace. Oh, and again, beware of things like Notepad for adding CRLF characters. All right, so the VI editor, this is entirely keyboard driven. To use it, we just have to run the command VI to open a file. It will either open an existing file with that file name, or it will create a new file. To do view only, we can use the -R. To exit a file or save, you can do, you'll have to hit escape and then :Q or :Q exclamation point to quit without saving. To actually start typing stuff into the file, you have to go into insert mode. And you do that by pressing I. And then once you hit I, then it'll start accepting what you're doing as text rather than as commands. Okay. So like I said, all keystrokes there are interpreted as text. If you're not in the I mode, if you're in the command mode, then there are different keystrokes that do different things to the text file. So let's just look at this real quick. All right, so I'm going to go back to where we were, fundamentals of Linux. And there's a readme.txt. So if I do vi readme.txt, all right, so that's going to bring up the vi command. So now I'm in command mode right now, right? So if I'm hitting, I hit I. So now I'm in insert mode. You can see on the bottom of the screen. I want to escape insert mode. I have to hit escape to do so. In here, so now I can do things like I just hit D twice real quick and it deleted a line. But let's say I want to add in something. So now I can hit I, I'm in insert mode, and I can say, this has been modified by Wes. All right, and now I want to save it or quit. I hit escape, colon, and then X, that's going to save and quit. All right, so now if I do it again, you can see it still says this has been modified by Wes. But now I'll add in something like, what if I do this? So if I do X, Q, and then exclamation point, VI readme.txt. Okay, I just quit without saving. And so it didn't save all those deletions I made. All right, so take a few minutes and play around with that readme.txt file using VI. All right, we're going to move on now to remote access and file transfer. So I believe this is the last topic that we're going to be covering. So we talked about SSH, and it's a way to communicate with encryption to a remote system. And so you can SSH into Grace using like MOBA Xterm on Windows. So who has a Windows machine with MOBA Xterm on it? Richard's using it right now. Okay. If you want to take some time, you can download this on Macs. Who has a Mac? All right, it's easier. You just open up Terminal and you can SSH into our system. So if you want to take a minute to download Mobile Xterm and try to SSH into our system. Or if you have a Mac, just do so through terminal. And to do that, you just SSH space your name, your username at grace.hprc.tamu.edu. So I'll leave that up there for the Mac users. All right, so I hit enter, and now it's prompted me for a password. So I'm going to put in my password. Oops. All right, and so this is the same thing that was brought up through our portal, right? So this is something that we're used to now. All right. All right, so then I did exit, and now I'm out. My connection to that's been closed. If I want to work with remote graphics like we talked about with gedit, then you'll have to enable exporting. So let's try that. You just use the flag, the capital X. All right. So with that X11 enabled, I was able to type in gedit and then the name of a file. I used that DOS underscore example file that we had. And it brought up gedit on my machine so that I can make these changes here. So I can say echo changes, save, close, and then bash. I run, yeah. I forgot to do my DOS to Unix. All right, and then if I run that again, we can see it says this file contains CRLF line layers, and that it echo changes, which is the change I made in that nice GUI that popped up by allowing the X11 forwarding. So Mobile Xterm supports that automatically, so that's really nice. On Mac, you just have to specify with a dash capital X or a dash capital Y. All right, any questions on that right now? Did anybody try to access via Mobile Xterm? Did it work? All right, great. All right. All right, so we discussed this a little bit, the files and the clusters. I want to take some time and point out some of the other things that are available on our Open On Demand. We have interactive apps. So I'm sure a lot of you are from very different disciplines, but there are applications that you can use here. Jupyter Lab and Jupyter Notebook are really popular ones that you can launch interactively on our system. RStudio, if anybody does statistics, it's a really common software package. And some other things that are IGV is for viewing genome files. So that's something that I would use. But there are a lot of these interactive apps. And then we have our Grace dashboard. And that'll just bring up basic statistics about our clusters, our cluster things. front row. So Wi-Fi is real slow. All right, so just a number of different things. If you have running jobs on our compute nodes, you can look at that. And then again, files, handy file browser. All right. All right, so transferring files is another thing that will come up frequently. There are a few different methods of doing this. There's SCP, SFTP, rclone, rsync. There are a number of different GUIs that allow you to do this easily. So MOBA Xterm, again, allows you to transfer files between like your local machine and Grace. WinSCP is another popular one. FileZilla is a thing. And that's good for smaller files. We also have Globus Connect, which is a really fast data transfer method to transfer files between your local machine or between two different remote machines. And that will that's a kind of a web interface. You can also upload directly to our portal, which is really nice. So if you're on here, this is my home directory, and I'm just going to exit this. I'm going to create a file on my desktop. And then in order to transfer it to the Grace, you just drag and drop. So it's real nice. Upload one file, and it's uploaded, right? So a lot of GUI options for doing this, but you can also do it with the command line. So to do that, SCP is a really good method. So it is set up like this, where we've got SCP the command, then the local file that you want to copy. So in this case, it would be file.txt that I just uploaded. And then the path that you want to upload it to, including your login information for Grace and the actual path. So if I do, this is going to copy from my local machine to, let's say I want to go into the fundamentals of Linux. I could do SCP file.txt, that local file, and then wbashir at grace.hprc.tamu.edu, colon, and then this is where I put in the path. Undo scratch/user wbashir fundamental. What is it called? Like this? Is that right? No of? All right. All right, so now this looks a lot like just SSHing in, right? So it's asking for my password. All right, and it transferred. All right, so now if I go look in that directory, I should have scratch. Is anybody else having Wi-Fi problems right now? Oh. All right, so here it is, file.txt that I just uploaded at 12:22 p.m. All right, that's using SCP. You can also grab a file from the server and download it to your local machine. I'm going to download this README. And so I'll just do SCP. And then this time we switched the place. So wbashir at grace.hprc.tamu.edu. Scratch user wbashir fundamentals _ Linux. And then it is readme.txt. And I just put the period because that's where I wanted to download it. So you can see, like, this is one method of doing it, but it's a little more cumbersome than our portal. But now I've got the readme.txt file on my local machine. All right, any questions on SCP? No, we're good. All right. Some things to consider, though, to recursively copy all the contents of the directory, you can use the -R. However, if there are shortcuts in the directory, that can cause a problem. The -V flag is for verbose again. And -P is going to preserve all those modification times and the access times and all that, which is really, really nice. So if instead of creating, if you're downloading a whole directory, it won't have brand new information for when it was last modified. You can retain all of that information with that flag, which is really nice. All right, SFTP is another method used to transfer files between Linux machines. It works similarly to SCP. Just wanted to make sure that you are aware of it. We're not going to go into any details as we're about to run out of time. All right, skip that. All right, so yeah, we're about out of time. Yeah. So are there any questions over what we've covered today? Over any of the topics? Yes. Okay. Can you help? Any other questions? All right. Yes. It prints out information about what it's doing. So there's a lot more output. All right. Well, I encourage you guys to come back for intermediate Linux. I think that's in about a month. We'll cover more VI, but we'll also do a lot of cool stuff like awk and grep and sed and other topics as well. I think we have, is there food coming? Okay, yeah, there's pizza should be here any minute. So you guys will stick around and have some pizza. Otherwise, thank you for coming and participating. If you have any questions, I'll be around for the next hour or so. So feel free to ask. All right, thank you guys.